Good day my scholars, this is my school channel and my name is Abiola. Right here in this video lesson we are going to be going through the topic modular arithmetic. So we are going to look at the concepts, as well we are going to consider certain terminologies that have been used when it comes to the topic modular arithmetic. We are going to see how we operate addition, subtraction, multiplication, division and even exponential equations or exponential expressions when it comes to modular arithmetic. So I believe that this video lesson is going to be very interesting. All you just need to do is to stay with us because we'll be right back. You're welcome back to my school YouTube channel, and right here in this video lesson we are going to dig through the topic modular arithmetic. So at first you may ask, what is arithmetic? That's part, especially in mathematics, where you are dealing with numbers, you are trying to manipulate them, you are trying to carry out certain operations, okay? So like addition, subtraction, multiplication, like for instance I say 2 plus 2 equal 4, you can say that. So that is arithmetic, under certain guidelines or under certain properties. So when it comes to modular arithmetic, is that type of arithmetic, okay, that deals with whole numbers, that deals with integers, okay, and most times or basically, okay, in every sense, what modular arithmetic is concerned with, they include, okay, first, your remainders. Okay, so a modular arithmetic concentrates on remainders. Okay, so what is the remainder when I divide this number by this number? And as well in modular arithmetic, instead of you having the integers going on and on, okay, under certain condition which we refer to as the modulo, okay, you see the number wrap around. Like for instance, you want to talk about 12 o'clock, you want to talk about 1 o'clock, but there are some certain timings that you hear things like 15 o'clock. Or 1500, okay, yes, 1700. So you can tell confidently that 1700 is actually referring to 5 p.m. in the evening. How do we know that 1700 is 5 p.m.? It means that once you get to 12, okay, you're looking at a 12-hour clock, isn't it? So the timing changes to 0 and you start adding your 12. So 12 plus 1 makes 13, 12 plus 2 makes 14, 12 plus 3 makes 15. So you can see 1500 is actually 3 o'clock in the afternoon or 3 p.m. So that is one basic thing about modular arithmetic. That type of arithmetic or that dealings with arithmetic whereby numbers will wrap around under certain value, okay, under certain divisor, or which you can refer to as a modulo. So if I'm working in modulo 5, just like I said earlier in our video lesson on number basis, okay, whereby when you are working in base 5, the highest number you can have is 4. So the same thing in modular arithmetic, when you get to that particular modulo, okay, so if I'm working in modulo 4, the highest number will be 3. That tells me that I have certain numbers that express themselves, which are 0, 1, 2, and 3. Okay, so once it gets to 4, the system wraps, okay, it becomes 0 and 4, then you pick it again, 1, 2, 3, 4, 5. So you can see that in modular arithmetic, what you are concerned with that particular modulo, you are concerned with remainders. Okay, so that is the focus, that is the target of modular arithmetic. And as well, I mentioned integers, I mentioned whole numbers. In modular arithmetic, we do not deal with fractions. So your answer or your solutions should not be presented in fractions. So let's dig further into the concept that we have here. As well, we are going to talk about the application of modular arithmetic. But first, let's start with this. So basic terminologies, I've mentioned remainders. Like for instance, if I say 5 divided by 4, that will be 1 remainder 1. Okay, if I say 11 divided by 5, okay, that will be 2 remainder 1. So you can see that remainder means what is left. Okay, so in a setup for division, you have your divisor, you have your quotient, you have your remainder, okay, and you have your dividend. So like the example I just cited, 11 divided by 2, 2 is your divisor, 11 is your dividend, the 2 that you got on top, okay, that is your quotient, then the remainder, that is 1. So we say that. So that's one of the basic terminologies that we should know when it comes to modular arithmetic, remainder. Another thing is you will see the word modulo. Okay, so modulo is actually talking about that particular base or that particular value, whereby if you get to that value in that expression, you have to wrap it up to 0. Okay, so like for instance, let's say I'm working in modulo 7, or let me say modulo 3, okay, to make it accessible. So in modulo 3, I can write it this way. All right, I can put it into parentheses. So in modulo 3, what I should have, that means I have 3 values or 3 numbers, and they are 0, 1, and 2. Please, 0, 1, and 2. So we can see that expression. So when it gets to 3, it becomes 0. So when it picks next to 4, I will have 1, and I start all over again. So in modulo, you know, the number has to wrap up when you get to that particular base. Let me use that base. Okay, so basically you can also refer to as modular arithmetic as clock arithmetic. You know, that is one way that it was first introduced to us, you know, using the hour clock that we use to quantify time. All right, so that's one terminology. Then there's another terminology that is very important that we should get acquainted with. Okay, so we are talking about congruence. You know, congruence carries the symbol of equivalence. So like for instance, imagine I'm working in modulo 4. All right, so I can say that 5 is congruent, okay, to 1 in modulo 4. How is that correct, you may ask? Okay, it's because when you divide 5 by 4, okay, you get 1. Remember I said modulo deals with, or modular arithmetic deals with your remainder. So you can see that 5 has a remainder of 1 in modulo 4. So you can see it's congruent to 1. So what you are considering is your remainder. Okay, so this is a sign of congruence or equivalence. Okay, but in modulo we use congruence. Okay, so then we have some other expressions like, you know, when you see signs like this, okay, we actually use these signs so that we can be very specific, or we can make it obvious so that you can tell from observation that you are working under modulo arithmetic. Okay, just like when you see certain expressions like this. I believe you can tell that this is set operation, right? So the expression of putting our signs, our operation signs into circles, okay, is just one strong identification that you are working in or working with modulo arithmetic. So as we go deeper into the video, I'm going to unveil more terminologies or more terms or expressions that we should understand and apply correctly. So we have some basic operations, you know, just like you work around your arithmetic, you know, your addition, your subtraction, your multiplications, you know, your division. Okay, the same thing occur when it comes to modulo arithmetic. Of course, we have exponents, yeah, okay, so, but the way we carry out additions, subtraction, multiplication, or division in modular arithmetic is quite distinct. Okay, so we just have to follow some simple properties, some simple guidelines so that we can get our answer. So I've cited some examples here that we can work around or work with. So we can work around these examples. Okay, so we see this, we see 0 minus 3. Okay, 0 minus 3, we can tell that that is minus 3. Okay. In modulo 4. But if you look at it, we are talking about whole numbers, okay? We are talking about numbers. Your answer should carry a positive value, okay? So we can see what is minus 3 in modulo 4. We can find that out if we use the clock system, okay? Or we use the number line, or use the spiral, okay? Those are different methods that you use to solve modular arithmetic or questions arising under this concept. So you can use your clock method, okay? You can use the spiral, okay? The spiral is like you are building something like this. Probably I have 1, 2. You can see if I'm working in modulo 3, for instance, I have 1, 2, okay? Then I have 3, I have 4, and 5, you know, 0. Okay, so I'm going to explain all of this. So you can see that difference between them will just keep increasing by 3. Okay, so that's why you can say 5 is congruent to 2. in modulo 3. You can say 4 is congruent to 1 in modulo 3. Can we say that now? Okay, so if I have this expression, let me use the clock system. Okay, so I'm working in modulo 4. All right, so I have 1, I have 2, right? I have 3. So in 4 in modulo 4, that is 1 remainder 0. So this is 0. Okay, so I think we are good. So pay attention to this. So if I have 5 in modulo 4, for instance, so what will be 5 in modulo 4? Remember that your residual class, okay, should not be up to that modulo, and it should be the highest, okay, should be 1 less or lesser than the modulo. Okay, so let's now find out what will 5 be. Okay, so this is 0, 1, 2, 3. Okay, 4, you can see. So the 4 has become 0. So where will 5 be? After 4, this will be your 5. Can you see that? This will be your 6. This is 7. You can see this is 8. This is 9. This is 10. This is 11. Can we see that? This is 12. Just like that. So if you look at the expression here, the differences between these sequences, okay, they are just 4. 0 plus 4, you can see 4, 4, 4. I have 4 plus 4. I have plus 4. This is already 4, right? I have 4, 4. I have 4, 4. So you can see that. So we are now looking for minus 3. You know, this, if we are moving forward, we will move in clockwise direction. Okay, that's why you can see the addition of 4. So we are moving anti-clockwise direction. So where will be minus 3? Okay, so we know this is 0. Okay, so this is what we are going to have. 0, we are moving in this direction. Okay, so this begins with minus, this is 0, you are moving down, right? Minus 1, minus 2, minus 3, you have your minus 4, right? Then I move ahead, minus 5, minus 6, minus 7, minus 8. Okay, can you see that? So, you know, in your clockwise direction, okay, this is 0, 1, 2, 3, 4, 5, 6, 7, then anti-clockwise, right? You are moving in the opposite direction. So this will begin 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9. You can see that. So minus 3 is not actually minus 3, okay? If it was just base 10, remember, okay, you should have left it there. But we are working with positive, okay, positivity. So that will be your minus 3 in modulo 4 actually has a value of what? 1. Okay, so if you don't want to use this method, you can also use the number line method. All right, so we have 0, 1, 2, 3. Okay, then I have minus 1, minus 2, minus 3. So starting from 0, right? So I have 3, 2, 1. The next value in modulo 4 will be what? 0. The same thing happens here. Okay, that will be 3. This is already what we have here. So we know this is 0, right? So the next number will be 1, 2, 3, then 0 on the next value, 4. The next value will be now 1. That is on 5. We can see that now. So this is how another way you can use to determine. So you can see that minus 1 in modulo 4 is what? Is 3. As well, 5 in modulo 4 is what? 1. So you can just use the idea of, oh, 5 divided by 4, that is 1 remainder 1. Okay, you can see that. So if you don't want to use any of this method, you can actually try this out. You can just add this, your answer, to the modulo you are working in. So that is minus 3 plus 4. That gives you what? That gives you 1. So we can say that minus 3 modulo 4 is 1. Okay, so let's now see an instance whereby probably I have, let me say, minus 7, yes, in modulo 4. Okay, so I know something inside will say, oh, that should be minus 3. But I'm telling you that your solution for this expression, okay, let it be in positive, okay, positive integers. So what do you see there? Whole numbers. So that will be minus 7 plus 4, isn't it? Okay, so minus 7 plus 4, that gives you what? Minus 3. It's still negative. So what do? We still have this. So minus 3 plus 4, that gives you 1. Okay, so what if I have minus, let's say I have minus 6 or minus 5. Okay, if I have minus 5 in modulo 4, so how do I bring it in correctly? So that will be minus 5 plus 4. That gives me what? Minus 1. I can't leave it like this, so I have to bring it to modulo 4. So minus 1 plus 4, that is what? That is 3. So we can say that minus 1 in modulo 4 is 3. Or I can still say that minus 5 is congruent to minus 1, right? And they are both congruent to what? 3 in modulo 4. So you see that. So it's because you are working in that particular modulo. Whatever answer you have to get, you have to wrap them up, okay, within what this man or this value can carry. Okay, so remember the residual class. The highest must be 1 less than the modulo. Okay, so this is what we have for this expression. As we go deeper in the video, I'm going to still show us 1 or 2 techniques or different ways whereby you can tackle questions regarding subtraction, addition, division, multiplication, exponents, okay, when it comes to modulo arithmetic. So we've solved this. So we know that 0 minus 3 modulo 4, okay, that gives us what? That gives us 1 in modulo 4. So some presentation may omit the parentheses, fine, but I just like to have my expression this way. Okay, so let's see this, 8 plus 6 in modulo 5. Okay, so let's add up. We know that 8 plus 6, that is 14. Okay, so but we know that 14 cannot be expressed in modulo 5. So that means we have to break 14 down. So 14 divided by 5, or how many times can 5 go in 14? We know that 5 can go in 14. How many times? That is 2 times, right? Remaining 4. So remember I said that modular arithmetic deals with what? The remainder. So your focus is on who or on what? The remainder. So I can tell that 14, right, is congruent to 4, is the same or equivalent to 4 in modulo 5. Do we see that? Okay, so I can use the clock arithmetic or the clock system to validate this answer. Okay, let me quickly do that. So since I'm working around the value of 14 under modulo 5, so that will be 0, right? 1, 2, 3, okay. Let me bring it up to fill up the circle. So I have 3, I have 4, then 5. Okay, so after 5, okay, the next one, that will be 6, isn't it? This will be 7, this will be 8, this will be 9. Then afterwards, I have 10, isn't it? 10 plus this, 10, the next one is what? 11. I have 12, I have 13, I have 14, I have 15, I have 16, 17, 18, 19, then 20. So if you want to trace it out, where do we have 14? You can see that 14 is congruent to 9, to 19, to 4 in modulo 5. Okay, so basically, if we want to pin it down, write it properly, so we can see that 15 is actually 0 in modulo 5. Okay, 14 is 4 in modulo 5. You can see 8 is 3 in modulo 5 because 8 divided by 3, that is 1, remainder 3. So remember, you are concerned with the remainder. That is what gives us the value that we have. Yeah. So that is for addition. Of course, I can carry out this addition in another method. So I'm going to show you that method very quickly. Okay, so I can decide to use their modulo to carry out this expression instead. Their remainder to carry out this expression. So since I'm working in modulo 5, 8 in modulo 5 is what? That is 1 remainder 3, isn't it? So that is 8 in modulo 5 is actually 3. Remember that 8 in modulo 5, it means 8 over 5, right? That is 1 remainder 3. So what am I concerned with? The 3. So I know that 8 in modulo 5 is actually 3, isn't it? Then what about 6 in modulo 5? That is 1, but we can confirm that again. 6 in modulo 5. So that is 6 over 5. That is 1 remaining 1. Do we see that? Okay, so I can add this, their modulo, their remainders together to get the answer. So let's see. You know the sign here is plus, so let me put the plus sign. So 3 plus 1, that is 4 in modulo 5. So I've actually reviewed one of the properties that you'll be using concerning basic operations in modulo or modular arithmetic. So this is your answer, 8 plus 6 in modulo 5. Okay, that should give you 4. So this should be 4 in modulo 5. So what about 18 times 17 in modulo 5? You know, I can decide to use my normal multiplication. Okay, let's do that. Let's do that. 18 times 17, very quickly. 7 times 8, that is 56. I write 6, I lift 1. Remember, if you have your calculator, you can punch it and skip through this method. 7 times 1, that is 7 plus 5, that makes 12. 1 times 8, I have 8. 1 times 1, I have 1. Right, so I have 6. 2 plus 8, that is 10. Right, 0, I lift 1. 1 plus 1, 2 plus 1, that is 3. So I have 306. So that is 306 in modulo 3. So remember, you can divide. Okay, so let's divide. So 306 divided by 3. 3 here 1, 3 in 30, that is 10. 3 in 6, that is 2. Remainder what? 0. So what will 306 be in modulo 3? I know you've gotten your answer. So the answer is 0 in modulo 3. That is, you can say confidently that 306, right, is congruent to 0 in what modulo? In modulo 3. You can say that. So in modular arithmetic, what your target is about is this remainder. Okay, make sure that you do not leave your answer in fraction or decimal form. Okay, so I'm going to use another method to confirm this expression here. Okay, so I know that this is 0 in modulo 3. So let's see another method. So I can actually find their remainders, okay, and multiply them together. Okay, so 18 in modulo 3, that is definitely 18 divided by 3, right? That makes 6, remainder 0. So that means 18 in modulo 3 is what? 0. Okay, so that will be 0 times 17 in modulo 3. How many times will 3 go in 17? That is 5 times remaining 2. So that will be times 2. 0 times 2, that still makes 0 in modulo 3. Okay, so I've just invented some of the properties that are involved when it comes to modular arithmetic. As well, it has applications, real life applications, like when it comes to your ISBNs, your other banking techniques or banking system. Okay, you invent or introduce this concept. Okay, of course, when you're also trying to read time, okay, using your clock. All right, so then as well, when it comes to cryptography, okay, you have to invite or implement the use of modular arithmetic. This is going to be a very interesting topic. Please, all I just need you to do is to click on the link in the description below. It's going to take you to the My School website. There we have provided you with enough and simple guidelines on how you can have access to this full video content. Okay, so I believe that you are going to enjoy the full section of this presentation. Okay, so do not forget to hit the like button, click on the subscribe button, and always tap on bell notification so you can get alert immediately we upload the next videos just for you.